today's video is an introduction to motion, some basic concepts about it. Yep, they're moving.
Things
It's
move.
motion. All right.
Move.
Now, before we even get started, here are a few quick facts. Did you know that even though you guys are all standing still right now, you're actually moving quite a bit?
Liar.
Well, here, think about it. So the Earth moves around, rotates around an axis, right?
Okay.
It actually rotates at a rate of 0.46 kilometers per second. Okay.
That seems that's a small number. That's got to be slow,
That's
right?
Well,
It's
if
more
you
like
translate that to maybe terms we use,
It's really slow.
I think.
yeah. If you translate that to terms we use kind of every day, that is 460 meters per second.
Okay.
So, 460
So that's almost an
meters
entire
takes every
lap around the
second?
track in a second. If you
So that's
translate,
kind of fast.
if you convert that to miles per hour, it's actually 1,070 miles an hour.
I'm moving
So
at 1,000 miles an hour right now.
So basically, the speed that I move when I run.
It's awesome.
Yeah, basically.
All right.
Yeah,
Okay.
Pretty close.
You're faster than a plane, huh?
Oh, yeah.
Anyway, so, well, not only that, though, not only are we rotating that fast, but we're actually orbiting around the sun, right?
That I did know.
We do that very, very fast at 30 kilometers per second. That translates to 67,108 miles per hour. So actually, at this very moment, anyone watching this video even is moving at least 67,108 miles per hour.
No need to go to the
Okay.
gym, guys.
That's ridiculous.
But wait, there's more. Because the sun doesn't stay at a fixed point either. The sun rotates around the center of the Milky Way, the big galaxy that we're in. Now, the sun's moving around, and therefore Earth's traveling around that at about 240 kilometers per second. So 536,864
miles per hour.
miles per hour. But not only that, the Milky Way is traveling through space really, really fast. Now, this is more of an estimate, 600 kilometers per second about. So that means at any given moment, you're actually moving at about 1,342,161 miles per hour.
So remember that
Hope you're
next
not
time
motion
somebody
sick.
says get out and do something.
That's
Say,
definitely-
I'm already moving over 1 million miles an hour. What more do you want?
Well, so how about
Like a
this,
fart
though?
in the wind.
Why do we, well, why don't we say then when we're driving our car, I'm going over 1 million miles per hour? Why don't we ever say that?
I'm guessing because since we are moving at that speed already, we don't recognize it. Like,
Right.
We don't feel that motion.
Yeah, we're not feeling like we're moving that fast.
Right. And
But-
that's because, what do we measure motion in relation to?
A
To
fixed
where
point.
we're at, like
Yeah.
to
Something you
us.
can see, the background.
Right.
But I bet if you stopped the spin of the Earth real fast, we'd all fall over.
Yeah, we would.
So
'Cause
right now you
objects in
guys
motion
aren't
tend to
moving,
stay
but
in-
if I run back and forth, I seem like I'm moving relative to you, but you guys
True.
seem like you're moving compared to me.
Right. So this is all,
Kinda
this
weird.
whole concept is talking about what's called a frame of reference.
Ah,
Okay?
that seems like
So-
a big idea.
That is the area in which motion is being measured from. Now, the most common point of reference we measure from is the Earth. So if I say I'm driving 30 miles per hour, that means in relation to Earth's surface, I am moving 30 miles every hour.
Right.
Okay?
So like the ground.
So you're basically
Right.
discounting the
Trees.
movement of the Earth because you're
Yep.
moving with the Earth. So we're saying, hey, right now I'm doing 0. Now I'm moving about 3 miles an hour.
Right.
Yep.
Something like that.
Makes sense.
Okay.
Probably be a good thing to write down.
Yeah. So anyway,
Frame of reference is a big
and
idea.
it really is, and we can go all day on point of reference, but
Sure.
I
Talk
think
more
we're
about
gonna,
that in class.
yeah. But anyway, so now we're going to talk about the different types of motion. I'm going to let you guys.
And,
Alright.
and the first type is, well, I don't know if it would be the first type. One of the types is called translation. And translation is literally moving from one place to another. So going from Gurnee to New York, if you want to go visit the Statue of Liberty or whatever, that's translation. You don't have translation, though, unless you end at a different point from where you started. If you walked and just came right back to the same spot, that's a different type of motion.
Yes.
That's actually
Revolution,
Revolution.
which is just translation in a circle.
Yep.
So basically what happens, rather than go from point A to point B in kind of a straight line or a relatively straight line, you're revolving around, like the Earth revolves around the sun.
Right. Think NASCAR.
like going around a track. Yeah.
Yeah.
Or even
Anything, or you're running around a track, or say you make a trip from home to school, then
Back
from
to
school
home.
back home at the end of the day, you have revolved from your home to school and back home again.
right.
Yep.
So it's just translation in a circle.
Now this gets confused with another term, which is also kind of a circular motion, and that
Yes.
is rotation. Now all rotation is, well, Mr. Black's rotating right now. He's staying actually at a fixed point, but he's moving in a circle. Okay? That point that he's fixed on is an axis. Do you want to hand me that? Well, first of all, Mr. Harkins is showing this with the globe, okay? There's an
our
axis that's
axis.
staying still, and the sphere is turning around that axis. Or another way of putting it is we have this bike wheel, right? The axis is right here. Okay, that axis stays still, but the object moves around that axis. Do you really want to do that?
It's like a saw movie.
Why don't I spin it really fast and see how
There
that...
we go.
Stick your fingers in the spokes. No, we're not going to do that. Anyway, so that's what rotation is. It's a fixed point and it's moving around that. Whereas revolution means the object is physically moving around in a circle and changing location.
Perfect.
So your tires will rotate on your car, but you may revolve
around the
places
parking lot.
or translate as you drive.
And the outside of the tire still stays around that axis.
Yes,
on
yeah,
that,
the axis
remember?
is what it spins about.
Cool.
Almost seems like we're going to use this in a couple weeks to build our own cars.
Yeah.
Most likely.
Right.
Two of the things you got are distance versus displacement. I'll handle distance. Basically, distance is just the physical length describing the amount of space between 2 points. Like
That
how
sounds
far you
complicated.
go.
Let's
Yeah.
simplify
It's
that.
the total travel that you move.
Yeah.
So like if I walk from here to the Newport Library, let's say, if I just walk straight down the street, I have a distance I travel, right? What is that about?
About 3 blocks.
About 3 blocks. But let's say instead of walking straight down the street, I go over to Grand and down Grand and then up the next street all the way back over to Washington and then back to Newport.
Mm-hmm.
My distance is going to be greater because I walked
Yeah, you
farther.
may walk 25 blocks,
Right.
but your displacement from where you started is still 3 blocks away.
Right.
Because you started here, you ended up here, and I don't care if you went in a straight line or you went all over the place, went to the moon, came back down, and then ended up at that library. Your displacement is just the distance from where you started to where you end up, basically.
Right.
That's what it is. It's the shortest possible distance between a start and a stop. The
So
beginning
another
and the
way to
end.
think of it is think like displacement is is like how far you travel from A to B, but distance is including the pathway that you took to get
Yeah.
there.
Right.
And we have good demos for that in class. We'll show
Right.
you guys all kinds of stuff.
The way-
do it. It's really neat.
The way I like to think of it is like, you guys know those pedometers that you like, they count the amount of steps you took?
Yeah.
Like, pedometer measures the distance you walk.
Right.
But it doesn't, the displacement is just like, you start measuring at a certain point and then you stop. And the closest possible line you can draw between those 2 points, that's your displacement.
True.
Yeah.
Yep. So, anyway, so here's a little example question. Someone starts at point A and walks to B, and then they travel down to C, and then travel down to E, okay? So, the total distance travel would be when you add all those routes together. So you have, the distance is 5 plus 3 plus 2, right? So what's
Right.
that total distance?
10.
3, 2 is 10.
10, okay? But the displacement is the closest between those 2 points. So you wouldn't take any of this into account with displacement. You just go from A to E. And you can see there it is 4,
Yep.
okay?
Cool.
And
So-
we'll work with this in class. There's a bunch of cool examples we can use for that too, guys.
Very true.
Right, and then like here's another one. Going from B to A, the distance would be 3 plus 5, right? 8. And then the displacement would be just going from D to C to A, like that closest route. So it's about 6.
So it's the most direct route.
Although really that's not a totally straight line, so maybe that's not even correct. But anyway,
Yeah, based on our stuff there.
we don't need to do another one of these, do we? No.
No, we can cover
We're
these things
good.
in class. We're pretty good on this stuff.
All right, so we're going to end this by just talking about speed.
Okay, so you guys, speed is just the change in a distance over time by whatever's moving. In this case, we call it the object. It could be you, it could be whatever.
Yep.
So we're talking about distance and time. Miles per hour, meters per second.
What does per
Distance
usually mean?
Per time, divided by.
Right,
So
okay.
it's distance divided by, or that's why we say over time.
Yep. And it's
So
how-
miles per hour is a measurement of speed.
sometimes it's also called rate. Just
Yeah.
Yeah,
rate of
rate,
travel.
all of these
Yeah.
different things, or how fast you're traveling. that
Right.
So
kind of thing.
is miles per hour the only measurement of speed?
Oh,
Nope.
no.
As long as you have a unit of measurement for length divided by a time measurement,
Okay.
you've got speed.
So you could have like meters per second. In fact, I
Yep.
think that's what we're going to use mostly. But
Probably.
Meters
Could
per
you
second,
could you do
kilometers per year.
could you do miles per second?
Sure.
Yeah, you
If you're
could.
talking tectonic plates, it could be centimeters per year.
Right.
Any of those things.
When I'm driving, I like to think of my speed in miles per minute.
Miles per minute makes
Or
it
in
seem
the
like
plane.
you're really,
Yeah.
like going slow.
Yeah. Or when I'm running, I like to think of miles per second because no, I don't. Anyway, so here's now when we're talking about speed, there's actually 2 categories of speed. An average speed is if you take into account an entire trip you take the time and you take the distance you cover and just kind of average it out.
Yep.
So let's say I went 200 miles in 4 hours. I would just take 200 and I would divide that by 4, and that would be 50 miles per hour. But here's the thing:
That's
when
an
you
average speed.
when you guys drive, when you drive somewhere, do you go the
Sometimes.
same exact speed the entire time?
Always.
No, I have to stop sometimes for stupid red lights.
Yeah,
Sorry.
or speed limits. You know, like my neighborhood, I can only go 25.
And then you probably go faster when you get on like the highway and stuff like
Right.
that. Okay, so the point is you're not taking that exact same speed the whole time, right? That'd be unfair to say that person went exactly 50 miles per hour the whole time.
It's an
Right.
average.
They had different times where they were at specific speeds. So if you're talking about the speed of an object at one single moment, like maybe when you check your speedometer and you look at your
Right.
speed, that's what's called the instantaneous speed because it's in an instant what the speed was.
So a car's speedometer only gives us instantaneous.
Right.
We look down, we see how fast we're going at that second.
Right.
2 seconds later,
Yep.
we could be at a totally different speed.
Very true. Now
Right,
some
especially if you
cars,
hit the brakes.
yeah, and some cars will have a setting where you could switch and look at what your average speed
Right.
is, and that's
Do the
including
calculation.
your calculation for since you started driving that car, like when you first bought it. So it's including everything. So
Right.
Cool.
cool.
So anyway, real quick practice problem. If you
I like practice.
Yeah, we're driving 40 miles from Gurnee to downtown Chicago, and it takes 1.3 hours. That seems like slow time.
Yeah.
But anyway, what is your average speed? So you take that distance, which is what?
40.
Miles.
40 miles.
Oh yes.
And what's the time?
Units.
Ah.
No naked numbers.
1.3 hours.
Yeah,
Right,
1.3
divided by
hours.
1.3 hours, and that equals 30.8 miles per hour.
So about
very
31 miles
Should
an
be a
hour down
division
there.
sign there, but
Yeah.
anyway. So that's all that there is to calculating time. Notice I have miles per hour.
Yeah,
Miles.
miles per hour.
All right, make sure you do your checkpoint.
Yeah, guys, do your checkpoints on these things. Finish strong. We're almost done.
All right.